Hello calculus students, we're here in section 1.3, estimating limit values from graphs. And here we're going to be starting off looking at some tricky problems when you have composition of functions. So we're trying to find the limit of the composed function f of g of x as x approaches 4. So we can't just put g of 4 in. G of 4 does not even exist. So let's look how we're going to figure out this limit. So the first thing we're going to do is we're going to look at the limit of our g of x function by itself. So that's the inside function as x approaches the number 4. Now if you notice this number, we're approaching 4 from both the left and the right hand side, since this is a general limit statement up here as x approaches 4. So look at our g function here in blue. As we approach 4 from the left and the right hand sides, looks like the function g is approaching 0 on both sides. So we do have that this limit is going to equal 0. However, we are approaching 0 through positive values on both sides. So we're looking at values greater than 0. So our function g of x is approaching 0 through positive numbers. That's very important that we notice that. Now we're looking at our value of the limit of the f of x function as x approaches 0 from the right. So as x approaches 0 from the right hand side. So the limit of f of x as we approach 0 from the right hand side, we're looking then now at the red graph, and we want to approach 0 from the right hand side. So we're approaching the values of 0 from the right hand side, which means we're using this part of the graph, and we are approaching -2. Since the limit of f of x as x approaches 0 from the right hand side is -2, my original limit question, limit value is -2. Now these are kind of tricky, so we're going to do a couple more examples. Here's the same graph, but we have a different limit statement. It says limit of 6 minus x squared, g of 6 minus x squared as x approaches 0 from both left and right. So this time we have a composed function which is not actually graphed. So let's do a quick sketch of that. So on an xy axis, that would be a quadratic opening down. This would be at a height of 6. So as we approach 0, we're doing the same thing. Then we're going to look at the limit then of our 6 minus x squared as x approaches 0 from both left and right, because our general limit is the question we're asked up here. So the limit of 6 minus x squared as x approaches 0 clearly looks like it's going to be 6. However, if you look at this graph here, as we approach 0 on the x, this graph approaches 6, but from numbers less than 6. So from under 6. So now we're going to look at the limit of our function g of x as x approaches 6 from numbers less than 6. So or left of 6. So now we're looking at the blue graph. We're going to be approaching the number 6 from the left-hand side. Consequently, the function climbs up to this value here, which like we come straight across, and that's at a height of 1. So my limit value is a 1. So my original limit statement has a limit of 1. Now let's look at the third example. My third example is finding the limit of f of x minus 3 as x approaches 3 from the left. So it looks like maybe some people might just throw a 3 in here and get 0 and then say, oh, limit of f of 0 must be the function value, which is at 0. But let's just try and see what happens. Let's not jump to any conclusions. So we're going to apply the same concept. We're going to look at the limit of x minus 3 first, as x approaches 3 from the left. We don't have this graph, but we can, I guess, quickly put it in. So let me do that real quick. Say we have x minus 3 would pass through 3 comma 0, and it would also pass through, I guess, 6 3. So let's start here and let's draw. So here's a picture of our graph basically. Okay, so there's my x minus 3 function. So that function, the limit of this function as x approaches 3 from the left. So here's my 3. So as we approach 3 from the left, we are climbing up through here, up through 0. So the limit is 0. However, it's a 0 through the negative numbers, or less than 0. So it's very important that we actually have a little minus sign here. Okay, now we're going to be looking at the limit of our f function as our x values approach 0 from the left-hand side. And lo and behold, we're looking at exactly what we thought the answer would be. As we approach 0 from the left-hand side, my function does approach 0. Now, the reason why I said we have to look through this carefully is because if we had switched this and had 3 minus f of 3 minus x, then our value of the limit of the 3 minus x would actually approach 0 from the right-hand side, and our limit would have been -2. So you got to be careful.